Hi everyone. So up till now we have completed 11 lectures and this is going to be lecture number 12, right? So we have successfully completed the coordinate systems, right? So we have completed rectangular coordinate system and then cylindrical coordinate system and then spherical coordinate system, right? So in this lecture we try to solve some problems based on this coordinate systems, right? Okay. So now see here, see in the last lecture, that is in a spherical coordinate system, right? So what are the surfaces we got here? We got three surfaces. So one is a semi-circular surface, right? So here the variables are nothing but what? The variables are nothing but r and theta. Yes or no? The variables are nothing but r and theta. So this is the semicircular surface we got. So this is one surface. Here the variables are r and theta. So we call it as what? Phi equal to constant plane. Phi equal to constant plane. Right? Okay. Next, the variables are theta and phi. So we call it as r equal to constant plane. So for r equal to constant plane, what we got here? We got the surface of the sphere. We got the surface of the sphere. We got the surface area of the sphere like this, right? Okay. Okay. So for r equal to constant plane. Next, next for theta equal to constant plane. For theta equal to constant plane, we got what? We got the surface of a cone. The surface area of a cone we got, right? So this is z axis. So this angle is theta, right? So for theta equal to constant plane, we got surface area of a cone. For phi equal to constant, we got semicircle. For r equal to constant, we got surface of a sphere. For theta equal to constant, we got surface area of a cone, right? Okay. Okay. So I have told that by taking any of these surfaces and extending those surfaces in their perpendicular direction. Sorry. By extending those surfaces in their perpendicular direction, we are going to get what? We are going to get the volume, right? Okay. Okay. Now see here, let us check that one here. So this is phi equal to constant plane. So its direction is what here? Its direction is in a phi cap direction, right? So its direction is in a phi cap direction, right? Okay. Okay. So how I can represent here a phi cap? Okay. So if I consider this as the semicircle, right? So a phi cap. Okay. So this is the semicircle here, right? Okay. Okay. So its direction is what? A phi cap direction. That means if you draw the normal to this one, so it is going to point in what? It is going to point in a phi cap direction. So here it is very difficult to represent that direction. Okay. Okay. But we know that a phi cap means what here? A phi cap is the normal drawn to this what? Is the normal drawn to this semicircular surface. Understood? Okay. So if you rotate this semicircle here, if you rotate this semicircle in a phi cap direction, if you rotate this semicircle in a phi cap direction, what you are going to get? You are going to get the volume of the sphere or not? Yes or no? So take this total surface of the semicircle and rotate it in its perpendicular direction, extend it in its perpendicular direction. So its perpendicular direction is nothing but a phi cap. So if you rotate this semicircular surface in a phi cap direction, then what you are going to get? You are going to get the volume of what? Volume of sphere. right? Okay, okay. So similarly, this is r equal to constant plane here. Here the variables are nothing but theta and phi. So this is r equal to constant plane, right? Okay, okay. So let us say this is the center of the sphere. So here I will draw the sphere. Right, okay, okay. So this is the center of the sphere, let us say, right? And AR cap is going to point in this direction, right? Okay, so it is radially outward, right? Okay, so now this is r equal to constant surface. So what I have told, take this surface and extend in its perpendicular direction, then you are going to get what? Volume of the sphere. See here, take r equal to 0 here. Here you have to extend this surface of the sphere in AR cap direction, that is in radial direction. Understood? So take a small sphere here, take a small sphere whose radius is approximately equal to 0, approximately equal to 0. Take a small sphere. Understood? R tends to 0. Now what you have to do? So just go on vary r here. So if you go on increase r, that means if you extend this spherical surface in r direction, that is in radial direction, what you are going to get? You are going to get the volume of the sphere or not? It is just like if you place the concentric spheres, as r goes on increases, it will be just like placing the concentric spheres one after the other, one after the other. So that is going to give you what? That is going to give you volume of the sphere. Understood? So similarly, here this plane is nothing but what? Theta equal to constant plane. So if you extend this surface in its perpendicular direction, that is in theta direction, then you are going to get the volume of the sphere. See, for example, let us consider theta equal to 0 here. If you consider theta equal to 0, you are getting what? You are going to get 0 cone like this, 0 cone. There will be no cone at all, okay, when theta equal to 0. So now we have to extend, or you can say theta tends to 0. So in that case, you are going to get almost 0 cone. Right. Now you have to extend this conical surface in which direction? In theta direction. Understood? So if you go on extend, theta here, if you go on extend theta, so then what will happen? If you go on increase theta, what will happen? This cone is going to expand like this. Yes or no? It is going to expand like this as theta goes on increases. So when theta becomes 90 degrees, it will form a bigger circular surface. Next again, if theta goes beyond 90 degrees, then it will go like this, and when theta equal to 180, again it will become 0 cone. Okay, so it will start from here, so it will go like this. Understood? So it is going to expand like this, right, and becomes a bigger circular surface here, and again it is going to decrease, and here it becomes 0. So if you combine all this here, what you are going to get? You are going to get the volume of the sphere, right? Okay, okay. So that's what I am saying, that is you can take any of these three surfaces and extend those surfaces in their perpendicular direction. You are going to get what? You are going to get the volume of the sphere, right? Okay, okay. So this point I have not explained in the previous lecture because of the time factor, so that's why I am explaining this here, right? Okay, so I hope this point is crystal clear. Next, we have determined, the differential volume, and also we have determined the total volume of the sphere, right? Okay. So next, we will try to solve some problems in this coordinate systems here. So let us solve some problems in this coordinate systems, based on coordinate systems, right? Okay. So the first problem, write down the first problem. Convert, or I can write represent 3, 5, 2 in cylindrical and spherical coordinates. So represent this rectangular coordinate. See, whenever they have given the coordinates, you have to identify which coordinate system it is. Understood? So here they have given 3, 5, 2, which means it is rectangular coordinate system. Understood? So they have given the coordinates in rectangular coordinate system, and they are asking us to determine in terms of what? Cylindrical and spherical coordinate system. Okay, so it is very simple and easy question here. So do it here, do it. So pause the video and try to solve the problem. Pause the video and try to solve the problem, right? Okay, okay, okay. So see here, I hope you got the answer, right? So in cylindrical coordinates, that means you have to determine rho, phi and z. So what is the relation between how we can represent this rho in terms of rectangular coordinates is nothing but what? So this is x, this is y and this is z. So rho is equal to what? Square root of what? Square root of x square plus y square, which is equal to what? Square root of 3 square plus 5 square, which is equal to square root of 9 plus 25. Yes or no? 9 plus 25 is 34. Right. So rho is equal to square root of 34. Right. Next phi. Phi is equal to what here? Tan inverse of what? Tan inverse of y by x, which is equivalent to tan inverse of what? Tan inverse of 5 by 3. Tan inverse of 5 by 3. So you can determine this one here. You can determine this one. Right. Okay. Okay. You can calculate it in terms of radians or in terms of degrees. Okay. Okay. So z is same as what here? Z is same as z. So that is 2. So in cylindrical coordinate system, rho, comma, phi, comma, z is nothing but what? Is nothing but root 34, comma, tan inverse of what? Tan inverse of 5 by 3. You can determine it in terms of degrees or radians, right? Tan inverse of 5 by 3 and z value is what? Z value is 2. So this is in cylindrical coordinate system. So similarly, we can determine in spherical coordinate system, right? Okay. So in spherical coordinate system, so r, theta and phi. So r is equal to what here? R is equal to, we know that square root of, it is square root of x square plus y square plus z square, right? And theta is equal to what? Theta is equal to tan inverse of what? Tan inverse of square root of x square plus y square divided by what? Divided by z. And phi is equal to what? Phi is same as what? Phi is same as in case of cylindrical coordinate system. So that is simply tan inverse of what? Tan inverse of y by x, right? Okay. So if you do this, what you are going to get? Square root of x square, that is 3 square plus 5 square plus 2 square. So which is equal to square root of 9 plus 25, 34, 9 plus 25, 34, 34 plus 4 is 38, root 38 you are going to get. Next here you are going to get a tan inverse of what? Tan inverse of square root of x square plus y square, that is 3 square plus 5 square, that is root 34 divided by z. Z is nothing but 2. Okay. So you can determine this value here, right? Next tan inverse of y by x, so that is tan inverse of y value is what? 5 and x value is 3. Okay. So you can determine it in terms of degrees or radians, right? Okay. So here r comma theta comma phi is nothing but what here? It is nothing but root 38 comma tan inverse of what? Tan inverse of square root of 34 divided by 2 comma tan inverse of what? Tan inverse of 5 by 3. Okay. Okay. So this is the value of r comma theta comma phi, right? Okay. So this is how you have to convert or represent the rectangular coordinates in terms of what? In terms of cylindrical and spherical coordinates, right? Okay. Okay. So I hope this problem is crystal clear. So next problem here, write down next problem. So next problem, represent 3 comma 30 degrees comma 5 in rectangular and spherical. Okay. So represent 3 comma 30 degrees comma 5. So here 3 comma 30 degrees comma 5 means you have to understand that this is nothing but rho and this is nothing but phi and this is nothing but z. So which means this is nothing but cylindrical coordinate system. So they have given the coordinates in cylindrical coordinate system and they are asking us to determine what? To determine in terms of what? In terms of rectangular and what? And spherical. Right? Okay. Okay. So now see here. Right. So what is the solution here? What is the solution? Tell me. Okay. So they have given rho, phi and z. You have to convert it into rectangular. So rectangular coordinates are nothing but x, y and z. Right. So we know that x is equal to what? X is equal to rho cos phi. Y in terms of cylindrical coordinates is nothing but rho sin phi. Z is same as what? Z is same as z. So it is very simple. So which is equivalent to rho is nothing but 3 into cos 30 degrees. Right. So 3 into cos 30, that is 3 root 3 by 2. Next, y is equal to what? Y is equal to 3 into sin 30 degrees, which is equal to 3 by 2. Next, z is same as what? Z is same as z, so that is 5. Right? Okay? Okay. So x comma y comma z, x comma y comma z in rectangular coordinates is nothing but what? Is nothing but 3 root 3 by 2 comma 3 by 2 comma what? Comma 5. So this is the x, y, z values. Okay, in rectangular coordinates. Right? In spherical coordinates here, in spherical coordinates, what you are going to get? Tell me. So convert this into spherical coordinates here. Convert this into spherical coordinates. So that means you have to represent r, theta and what? And phi. Right? R, theta and phi. See here, phi in spherical coordinate system is same as what? Is same as phi in cylindrical coordinate system. So here in cylindrical coordinate system, phi value they have given as 30 degrees. So here also phi is nothing but what? Phi is nothing but 30 degrees only. Right? Okay. So the definition of phi will remain same as in case of cylindrical coordinate system. So the value of phi will remain same whether it is in cylindrical or spherical. Okay. So that's why we can get directly phi equal to 30 degrees. Next, what is r here? What is r? How we can represent r in terms of a cylindrical coordinate system? See here, we know that r is equal to square root of what? In rectangular coordinate system, we know that r equal to square root of x square plus y square plus z square. Yes or no? Now here x square plus y square is nothing but what? X square plus y square is nothing but what? Is nothing but rho square or not? Yes or no here? Okay. See here in spherical coordinate system, so this is origin, right? So let us say this is r, let us say this is r. Okay. So here if you consider a horizontal circle here, so the normal distance from the z axis, to this point is nothing but what? Is nothing but rho. And if I consider this point as x comma y comma z, and this point is lying along z axis, that is 0 comma 0 comma z. Okay. Okay. So here rho is equal to what? Rho is equal to square root of what? Square root of x square plus y square. That is the distance from here to here. Right. Okay. So that means rho square is equal to what here? Rho square is equal to x square plus y square. So here this square root of x square plus y square, I can represent it as what? I can represent it as rho square. Right. Okay. So r is equal to what? R is equal to, I can write it as square root of rho square plus what? Rho square plus z square. So I have represented in terms of cylindrical coordinates. Right. Okay. So here they have given the rho value. They have given the rho value as 3. Rho value as 3. And z value is 5. Right. So therefore r is equal to what? R is equal to square root of rho value is 3 square, rho square is 3 square, and z square is nothing but what? 5 square. So which is equal to what? Square root of 3 square plus 5 square, that is 9 plus 25, that is square root of 34. Isn't it? Right now? So square root of 9 plus 25, that is root 34, right? Okay. Next, how to determine theta? So this is r value here, this is r value, right? Next, how to represent theta? See, we know that theta is equal to, so theta is equal to, we know that tan inverse of what? In rectangular coordinates, we know that theta equal to tan inverse of square root of x square plus y square divided by what? Z, and square root of x square plus y square is nothing but what? Is nothing but rho in cylindrical coordinate system. So you can represent theta is equal to what? Theta is equal to tan inverse of what? Tan inverse of rho by Z. So if you observe this right angle triangle here, this is theta, right? And this angle is nothing but what? 90 degrees. So from this right angle triangle, what is tan theta here? What is tan theta? See, the distance from here to here, the distance from here to here is nothing but Z. So from this right angle triangle, tan theta is equal to what? Tan theta is equal to rho by Z, rho by Z. Okay, so that's what we got here or not? Tan theta equal to rho by Z. So theta equal to tan inverse of rho by Z. Understood? Okay. Okay. So therefore theta is equal to tan inverse of what? Tan inverse of rho by Z. So what is rho value? Rho value is 3 and Z value is 5. Rho value is 3 and Z value is 5. So theta value is tan inverse of what? 3 by 5. Right? Okay. Okay. So we got r comma theta comma 5. So what we got here? R comma theta comma 5. So r value is square root of 34. Theta value is tan inverse of 3 by 5, right? And phi value is 30 degrees. Okay. So you can evaluate this one here, tan inverse of 3 by 5. You can evaluate with the help of calculator, right? Okay. Okay. Right. So next, next problem here, next problem. Represent 0, 0, 5. Represent 0, 0, 5 in cylindrical and spherical coordinate system. Represent 0, 0, 5 in cylindrical and spherical coordinate system. So pause the video and try to solve this problem here. Pause the video and try to solve this problem. Represent 0, 0, 5 in cylindrical and spherical coordinate system. Okay. Okay. So I hope you have tried this one. Let us check. Let us see here. So solution. Right. So in cylindrical coordinate system, we want to represent in cylindrical coordinate system. So this is x, this is y, this is z, right? So rho is equal to what? Rho is equal to square root of x square plus y square. Rho is equal to square root of x square plus y square, right? So this is equivalent to what you are going to get? X is 0, y equal to 0. So rho equal to 0, right? Next, phi is equal to what? Phi is equal to tan inverse of what? Tan inverse of y by x. So y is 0, x is 0. So 0 by 0, right? Next, z is same as what? Z is same as z. So that is z is equal to 5. So is this so here if you observe here, what we got here? What we got? Rho is equal to 0. Rho is equal to 0. See, if rho is equal to 0 here, if rho is equal to 0, there is no cylinder itself. Understood? Rho represents the radius of the cylinder. If rho equal to 0 means there is no cylinder at all, right? You are having simply z axis. See, if you consider this as the cylinder, right? This as the cylinder, okay, and this is radius rho. So if rho tends to 0, then this will shrink towards what? This will shrink towards z axis. So it will simply represent a line. Understood? There is no cylinder at all, right? So in that case, if you try to determine phi, what you are getting? Tan inverse of 0 by 0, which is not defined. Phi value is not defined or not? Yes or no? Rho equal to 0 means there is no cylinder itself. Okay, so representing in cylindrical coordinate system, this point is meaningless, right? Okay, okay. So that means we cannot represent this point 0 comma 0 comma 5 in terms of what, cylindrical coordinate system, because it is not valid. Rho itself is becoming equal to 0, means there is no cylinder at all. And also we are getting phi equal to tan inverse of 0 by 0 we are getting. Okay, we are not getting tan inverse of 1 by 0 or 2 by 0 like that. Okay, we are getting tan inverse of 0 by 0, which is not defined, right? Okay, okay. So this is not defined, phi value is not defined. Okay, so you cannot represent this 0 comma 0 comma 5 uniquely in terms of what, in terms of cylindrical coordinates. It is not possible, right? Now let us try for a spherical coordinate system. So if you try to represent in spherical coordinate system, r is equal to what? R is equal to square root of x square plus y square plus z square, which is equal to what? Which is equal to what you are going to get? Square root of phi square, that is 5. Next, if you consider theta, theta is equal to what? Tan inverse of square root of x square plus y square, divided by z, which is equal to tan inverse of what? Tan inverse of x value 0, y value 0. So 0 by z, which is equal to what? Which is equal to 0. Theta equal to 0. Next, phi is equal to what? Phi is same as in case of cylindrical coordinate system. So that is phi is equal to what? Tan inverse of what? Tan inverse of y by x. Here also what you are getting here? Tan inverse of what? Tan inverse of 0 by 0, which means here also this phi is not defined. So which means we cannot represent this point 0 comma 0 comma 5 uniquely in terms of what? Spherical coordinate system. Understood? Okay, okay. So what we got? Phi equal to tan inverse of 0 by 0, which is not defined. Here phi is not at all defined. So which means we cannot represent this point in terms of spherical coordinate system. Understood? Okay. So whatever may be the coordinate system, okay. So the point we can represent simply as 0 comma 0 comma 5 only. Okay, we cannot convert this into cylindrical or spherical, right? Okay, so not only this point here, you can take any point on the z axis, like a 0 comma 0 comma z. You can take any point on the z axis. So these points cannot be represented uniquely in terms of cylindrical and spherical coordinate system. Why? Means here x value is 0, y value is also what? 0. In this case phi is not defined. So that means the point itself is not defined in case of cylindrical as well as in case of what? Spherical, right? Okay, so we cannot represent the points that are lying on z axis uniquely in terms of what? In terms of cylindrical and spherical. Understood? So this is the note you have to make. So that's why I have taken this problem, right? Okay, okay. So I hope it is crystal clear here, right? Okay. Next. Okay. So next problem. So let us say I have given a point A is 2 comma 3 comma 4 and point B is 5 comma 7 comma 8, right? So I have given point A as 2 comma 3 comma 4 and B as 5 comma 7 comma 8. And if I ask you to determine AB bar, how you can determine here? It is very simple question, isn't it? I know that, right? It is very simple question. So just I have asked you to determine AB bar, that is the vector that is pointing from point A to point B. So here you are having point A, so that is 2 comma 3 comma 4. So somewhere point B is present. Let us say this is 5 comma 7 comma 8. I am asking to determine the vector that is pointing from A to B. So that is AB bar. So this is the vector I am asking. Okay, so whenever I ask you to determine this vector, what you will do here, what you will do, it is very simple question. So AB bar is equal to what? So as you move from A to B, the increment in x, what is the increment in x? Is nothing but 5 minus 2. So 3ax cap. So the increment in x will become the x component. Right. Next, as you move from point A to B, the increment in y is nothing but what? 7 minus 3. So that is 4ay cap. Next, as you move from A to B, the increment in z is nothing but 8 minus 4. Right. 8 minus 4 is 4. So 4az cap. So you can represent AB bar. You will represent AB bar as 3ax cap, 3ax cap plus what? Plus 4ay cap plus 4az cap. So it is very simple question, isn't it? So you can easily represent this one, right? Okay. So now if you observe here, point A I have given as 2, 3, 4. Point A I have given as 2, 3, 4. Right. And point B I have given as 5, 7, 8. Okay. So let us consider the units of this one. This is x coordinate. Let us assume its units is meters. Then the y coordinate will also be in meters. The z coordinate will also be in meters. And here for point B also, the coordinates, all the three coordinates are having the same units, that is meters. Understood? So in point A, all the three coordinates are having the same units, and for point B also, all the three coordinates are having the same units. Right? Okay. So that's why we have happily represented this AB bar. Right. What we have done, as you move from A to B, what we have done, we have determined the increment in x. Right. So the increment in x. So here x coordinate and here x coordinate, both are having what? Same units. So that's why we have determined the increment in x as 5 minus 2. Understood? And similarly, we have determined the increment in y. So here the y coordinate and here the y coordinate, both are having the same units, and here the z coordinate and here the z coordinate are having the same units. So that's why we have represented AB bar in a simple manner like this. Understood? And the overall units of this AB bar is also nothing but what? Is also nothing but meters only. So I can say AB bar is equal to 3ax cap plus 4ay cap plus 4az cap meters. Right. So it is going to have both magnitude as well as direction. That is a different story. Right? Okay. So keep this point in mind. So this is we have performed this operation in rectangular coordinates. Right. And one more point here, if you observe, what do you mean by 2 here? What do you mean by 2? So 2 is the distance from the origin along x-axis. Understood? And 3 is nothing but what? 3 is nothing but the distance from the origin along y. And 4 is nothing but what? The distance from the origin along z. So similarly for point B also, 5 is nothing but what? The distance from origin along x. And 7 is nothing but what? The distance from origin along y. And 8 is nothing but what? The distance from origin along z. So for all these points here, all these points are having what? Are measured with respect to the same reference point, are having the same reference point. So all the three coordinates here, all the three coordinates of each and every point in rectangular coordinate system are measured with respect to the same reference point. That reference point is nothing but what? Is nothing but origin. Right? Here x coordinate, y coordinate, z coordinate, and here x coordinate, y coordinate, z coordinate, or if you take any other point. Okay, so the x coordinate, y coordinate, z coordinate, everything, all the three coordinates are measured with respect to the same reference point. So that is nothing but origin. Understood? Okay, so keep these points in mind. Now see here. Now if I ask you, so let us say fifth problem, right? Okay, right. So let us say I am giving fifth problem. Let us take the point A in cylindrical coordinate system. So that is, let us say this is 3, 30 degrees, 5. Okay, and I am giving another point B. that is let us say 5 comma 60 degrees comma 7, something like this, right? Okay, so I have given point A and point B. Now this is given in cylindrical coordinate system. Now if I ask you to determine AB bar here, now if I ask you to determine AB bar, so can you write AB bar in this manner? Tell me. So AB bar is equal to, okay, so can you write in this manner? That is as you move from point A to point B, 5 minus 3, that is 2 arrow cap, and 60 minus 30 degrees, so that is 30, that is pi by 6 A5 cap, or 30 degrees, okay, I am converting into radians, okay, plus 7 minus 5, 2 AZ cap. So can I represent the vector AB bar in this manner? Can I represent the vector AB bar in this manner in cylindrical coordinate system? No, this is wrong. This is absolutely wrong. We should not represent in this manner. Okay, so why means, see here, we should not represent in this manner. This is completely wrong. See, why means if you want to represent a vector, AB bar, right, then what is the condition is the point A, all the 3 coordinates in point A must have the same units, and also in point B all the 3 coordinates must also have the same units. So whatever the units you are having for point A, okay, so all the 3 coordinates must have the same units, right? So in the same manner here for point B also all the 3 coordinates must have the same units, right? So then only we can represent what? We can represent we can represent this in vector form like AB bar, as we have done in rectangular coordinate system. Understood? And also one more condition is if you want to represent it as a vector quantity, all the 3 coordinates must be defined or measured with respect to what? With respect to same reference point. In rectangular coordinate system, we have seen that x, y, z coordinates all are measured with respect to the same reference point, that is nothing but origin. So whereas in case of cylindrical coordinate system, rho is measured, this is rho, yes or no? This is rho, and this is phi, and this is z. So if you observe, rho is measured with respect to what? Rho is the normal distance from the axis of the cylinder. What is the axis of the cylinder? We have considered z axis. So rho is the normal distance measured from the z axis. So here the reference we are considering as z axis. So while measuring rho, we are considering the reference as what? Z axis. Right. Next, if you consider phi here, phi is the angle between what? X axis and rho, and it is measured with respect to x axis. So here what is the reference we are taking? We are taking the reference as x axis. Okay. So while measuring rho, we are taking the reference axis as z axis, and while measuring phi, we are taking the reference axis as x axis, and while measuring z, we are taking the reference as what? Origin. Yes or no? We are taking the reference as origin. So all the 3 coordinates are measured with respect to what? With respect to different references. Understood? So here also rho is measured with respect to z axis, phi is measured with respect to x axis, z is measured with respect to origin. Understood? So all the 3 coordinates are measured with respect to what? All the 3 coordinates are measured with respect to different references, right? So that's why we cannot represent this in terms of what? In terms of vector like AB bar. So what are the conditions in order to represent in vector form, that is in AB bar? If you want to represent AB bar like a vector, then what are the conditions here? The first condition is all the 3 coordinates of point A and point B must be what? Must have the same units. Understood? Okay, must have the same units. So this is very, very important, right? Next, second point is what here? All the three coordinates of points A and point B must be measured with respect to the same reference point. Okay, so if these two conditions are satisfied, then only we can represent this in the form of what? In the form of vector, right? Okay, okay. So write down these conditions here. Write down these conditions. Okay, so write down these conditions. So that is in order to represent AB bar. Okay, so that is vector form. Vector form, in order to represent AB bar, that is in vector form, it has to follow two conditions here, two conditions. So the first one is both point A and point B must have what? Both point A and point B, like or I can write in this manner. Okay, the coordinates, all the three coordinates of point A and point B must have what? Must have the same units. Must have the same units. Must have the same units, right? Okay, so next condition, all the three coordinates of point A and point B must be measured with respect to what? With respect to same reference point. With respect to same reference. Right? Okay. Okay. So here, since these two conditions are not satisfying, we cannot represent this AB. We cannot represent this in form of what? In the form of AB bar. We cannot represent this in the form of AB bar. Okay. Okay. So what we have to do now? So how we can represent this in terms of AB bar? Why we are not able to represent in AB bar? Because it is not at all satisfying these two conditions. So that's why we cannot represent it as what? It as AB bar. Okay. Okay. So if you want to represent in vector form, then what we have to do? What are the problems we are having here? All the three coordinates are not having the same units. Here the units of this one is meters, the units of this one is degrees, and here the units of this one is meters, right? And here the units of this one is meters, the units of this one is degrees, here the units are nothing but meters. So all the three coordinates are not having the same units, right? And also all these three coordinates are not measured with respect to the same reference point. So in that case we cannot represent it in vector form, right? Okay, so these are the two problems we are having. So how we can overcome this? So what we have to do? If you convert all the three coordinates here, if we convert all the three coordinates into rectangular form, okay, then what will happen? All the three coordinates are going to have the same units, and all these three coordinates are measured with respect to the same reference point, that is origin. Understood? So similarly, we can convert this point B also into what? Into rectangular coordinates. So if you convert this into rectangular coordinates, then what will happen? All the three coordinates will get the same units, and all the three coordinates are measured with respect to the same reference point. Understood? Okay, so these two conditions will be satisfied. Then we can happily represent it in the form of what? In the form of AB bar. Right? Okay. So what we have to do? So in order to represent it in AB bar, so we have to convert this into rectangular coordinates, right? Okay. Okay. So point A is nothing but 3 comma 30 degrees comma what? 3 comma 30 comma 5. 3 comma 30 comma 5, and B, point B is nothing but what? 5 comma 60 comma 7. 5 comma 60 comma 7, right? So convert this here, convert this point into rectangular coordinate system. So what you are going to get? X is equal to, so this is row, let us say this is row 1, this is phi 1, and this is z1, and this is row 2, and this is phi 2, and this is z, right? So x is equal to, so x1, I am representing x1 is equal to row 1 into cos phi 1, which is equal to what? 3 into cos 30 degrees, which is equal to 3 root 3 by 2. Next y1 is equal to row 1 into sin phi 1, which is equal to 3 into sin 30 degrees, which is equal to 3 by 2. Next z1 is equal to what? 5. Next here x2 is equal to row 2 into cos phi 2, which is equal to 5 into cos 60 is 1 by 2, so 5 by 2. y2 is equal to row 2 into sin phi 2, which is equal to what? Row 2 is nothing but 5, sin 60 degrees is nothing but root 3 by 2. Next z2 is equivalent to what? Is equivalent to 7. So we got here x1 comma y1 comma z1 as what? This is point A as a 3 root 3 by 2 comma 3 by 2 comma what? Comma 5. And here x2 comma y2 comma z2 we got it as what? We got it as 5 by 2 comma what? Comma 5 root 3 by 2 comma what? Comma 7, right? Okay. Okay. So now if you want AB bar, so this is point B, in rectangular coordinate system, this is point A in rectangular coordinate system. Now if you observe here the units of this one, all the three coordinates are having the same units, that is meters, and meters. So all the three coordinates are measured with respect to what? The same reference point, that is nothing but origin. Understood? Okay. So now you can easily determine AB bar. So AB bar is equal to what? Increment in x, so that is 5 by 2 minus 3 root 3 by 2 into what? Into AX cap plus the increment in y. As you move from A to B, the increment in y is nothing but what? 5 root 3 by 2 minus 3 by 2 AY cap plus 7 minus 5 plus 7 minus 5 AZ cap. So in this manner we can represent AB bar, right? Okay, you can simplify this one here, you can simplify this one, right? Okay, so this is how you have to represent AB vector. You have to represent the AB vector. Okay, so directly whenever they have given the coordinates in terms of cylindrical coordinates, you cannot directly represent it in vector form. So the reasons I have already told. So the same is the case with respect to spherical coordinates also here. So in spherical coordinates, suppose they have given the point like 5 comma 30 comma 45 degrees and point B they have given as 6 comma 45 degrees comma, okay, so some 45 degrees comma 60 degrees. So like this, If suppose they have given the 2 points A and B, and if they ask to determine AB bar here, if they ask to determine AB bar, right? So here also the units of all the 3 coordinates are not same. Here this units is meters, so this units is degrees, and this units is degrees, and here also the units meters, and this is degrees, and this is in degrees. So the units of all the 3 coordinates are not same, right? Okay, and also here this is nothing but what? R. So R is the distance from the origin to any point on the surface of the sphere, right? The distance from the center of the sphere to any point on the surface of the sphere. So it is measured with respect to center of the sphere, R, right? And here this is nothing but theta. So theta is the angle between z axis and R. So it is measured with respect to z axis. And here 45 degrees, this is nothing but phi. So phi is measured with respect to what? X axis. Understood? So this R is measured with respect to center of the sphere, and this theta is measured with respect to z axis, and here phi is measured with respect to x axis. So the reference point, the reference is also not same. Okay, so since the units are different, and the coordinates that we have measured here are not having the same reference. Understood? So that's why you cannot represent it in vector form, that is in AB bar form. So what you have to do? Again you have to convert this into what? Into rectangular coordinate system, that is x1, y1, z1, and you have to convert this also into rectangular coordinate system, that is x2, y2, z2. So then only you can determine what? Then only you can determine AB bar, right? Okay. Okay. So whenever they have given the coordinates either in terms of cylindrical or in terms of spherical, then you cannot write them in vector form directly, right? So the reasons I have explained. So that's why what we have to do, you have to convert that coordinates into what? Into rectangular coordinates. So once we convert that into rectangular coordinates, then only we can represent them in terms of what? In vector form, right? Okay. Okay. So I hope it is crystal clear, right? Okay. Okay. So with this I am ending up this lecture here. With this I am ending up this lecture, right? And in the next lecture we will meet in the next lecture. Okay. Okay. So these are the few problems that I have taken in coordinate systems, right? So with this I am ending up this lecture. So we will meet in the next lecture. So I hope each and everything is crystal clear, right? Okay. So okay, then take care. Bye bye.